place and has to be released to get better decisions of the quality control and overall business decisions. And the last challenge, also in today's lab, are kind of, we mentioned before at the third challenge example, is this partially world of different Excel sheets, which will grow through products and year by year, or even product groups and parameters, and blown up and are even more difficult to handle. And about the traceability, about the audits, and the conformity of such files. I know by myself to handle those data and validating spreadsheets. And one day I came to the lab and double-click on one of these files, and it pops up an error message that this file can't be opened. And the next step was I went to the IT to restore that file. But all the data and the values we collected and enter in this sheet get lost. So we had no way to restore all of the values. Especially, let's imagine to delete some rows or even columns, how you can restore them and get back to all of the data. Another thing is to have the precise workflow and the work steps we had in mind. So there is a specific way to think about the workflows and the work steps. So for all of us, there is individual perception. So it's like a recipe we had in mind, what kind of steps we have to do in the kitchen to bake bread, for instance, or a cake, and what kind of steps we need with the specific raw materials to that. But if we look deeply into these single working steps and analyze them, we see that the process reality is much more complex. We use the term of a workflow network with downtime, with media disruptions, with different kind of decision makers who make this workflow even more complex. And if we have this status, we can think about what is the goal of a certain process, where we start and where we want to go. And then we can define the final step before the first step and streamline this process as much as possible. This is kind of the goal before starting or thinking of a digitalization. And to get this in a practical way about the topic of today's webinar, Power of LIMS and integration. So let's start. What should a connectivity and integration should be? It should be as lean as possible, as clean as possible. So only the features that's really needed to integrate a system like Omnis, or even the other way around like a LIMS, to make the workflow, which is based in the laboratory, more efficient. The second step is to make it as simple as possible. Reduce all the features and the workarounds and just focusing on the direct way and the direct functionality of such an integration. And make it as simple as possible, that is at any time basically possible to scale it up. And the last step is about the data security and the protection of that integration, to keep it standardized and as secure as possible, to also keep the status quo. This brings me over to the actually demo workflow which we want to present today and want to share. And now, luckily to hand over to Simon.
Thank you, Philip, for this nice introduction of the challenges we are facing today labs. It is important to stress that it's not about just digitalizing currently existing processes, but moreover, to redefine the processes when digitalizing them. Now we want to show you a video about a workflow between a LIMS system, here provided by OneLIMS, and an analytical software, the current analytical data management platform Omnis from Metron. We will see the creation of the analysis order, automated label creation to be able to always identify the sample uniquely. Then we will continue with the automated data transfer to the analytical software, starting the determination, and then automated sending back of the required results as part of the analytical method run in Omnis. Finally, we will see the centralized reporting, printing of a certificate of analysis in the LIMS. Additionally, towards the end, we will show how the audit trail within Omnis is dealing with data that are sent from an external system. And we will show that the flexibility of the way how the integration is done allows for a repetition of the analysis if something would have gone wrong, and an automated updating of the result in the LIMS. So as a short recap, the video will be playing in the media player. To see the screen in full size, please click the full screen button on the top right corner of the player. At the end of the video, please press the escape key to return back to the home screen, where you can then maximize again the presentation window if required. And with that, I hand over again to Philip to explain us the order creation, how it works in OneLIMS at the beginning of the video.
So let's start in OneLIMS. Let's create a quality control order. We start with a new order, freshly. We add a production as an internal contact. We add as an order number, can auto-generate it, or we use now 1, 2, 3, 4. We add the sample information. As a material type, we add juices and orange juice as an article. The test plan with the 2 parameters in it as pH value and chloride, and connected this to the Metron external lab. Now we checked the label for this order. We created the QR code and the predefined labels with all the information on this order. We can print it and stick it on the label. Now we move to the export to see if the test plan is connected and ready for the export. The top 2 lines is the test plan with the several test units, pH determination and chloride. And as checked, we can export them, and the status changing from not exported to exported now. So now it should get to the Omnis.
Now in Omnis, we have to log in. In this demo, we don't use a password to speed up a bit. We see now, after the login screen, the sample area of Omnis, where we manage everything related to samples and determinations. We switch now to a predefined search query, which gives us exactly the sample with a certain analysis number. Like this, we ensure that the sample is exactly the same as we have labeled during the order creation. You can see here the number 66. As you can see, we have 2 analyses to conduct according to the test plan. The sample is now transferred to a sample list where the determinations will be run. First, we check again if the sample is matching the analysis number. We Then, after renaming the sample list and saving it, we will start the analysis one after the other. You can see how the status changes from ready to running. And in this case, the results actually are just simulated to also speed up a bit the demo. What already took place automatically in the background during we see the second analysis running is that the result of the first analysis was automatically sent. This is part of the process which is defined within Omnis. We can see in the subsample history the response of the target system, in this case 1limbs, is status code 200 OK. This means the system successfully received the transfer data. Now we will have a look at the audit trail entries of the respective determination. The first entry regarding the creation of the sample shows us that it was created via the API, distinguishable by the client name of the external system and the used technical user. Furthermore, we see all status changes from ready to running, setting the determination start date, and so on. In the end, we see the status from change from running to completed.
In 1limbs, in the sample overview, we check the received values about the sample 66. As we can see, we approved this sample and check the certificate of analysis as the test report. With 2 clicks, we can open the test report and check the test plan for the sample 66. With another move, we can download as a PDF the test report and check them in the overview.
Now, at the end, we want to show you the flexibility of the way the integration is done. In case something went wrong with the first analysis, you can simply create a new determination and run it again. Also here, the results are sent automatically to 1limbs and updated there without any required user action. So after the video, we will go through the key points which you have to do and to consider during such an integration project. Eventually, you have to set up the software and create the analytical methods operating procedures which you will be using for the respective analytical orders. Furthermore, the process of how the order is created and how the sample receives its unique identifier via a label needs to be defined. You have to deal with the transmission of the data to the analytical software and with the transfer back of the relevant results to the limbs. A process to find the exact sample within the analytical software has to be established, and reporting monitoring is needed as well. Let us start with the setting up of the software, if needed, and the creation of operating procedures methods within Omnis. If you require a validation, this is part of the responsibility of the process owner. Metrum can support you here and also provide an installation qualification of Omnis, which guarantees that the software itself is working according to its specifications. You also have to define the mapping of the individual test plans to the operating procedure within Omnis, which is in the end reflecting the kind of analysis which you have to do as defined by the test plan. Additionally, you have to define the process of the order creation in the LIMS, creating the needed sticker labels, which enables to uniquely identify the sample towards all relevant systems. For example, towards a LIMS or the respective analytical software. You have to make sure that a sample reaches its correct and intended destination. Sample preparation should be ideally done during the analytical run as part of the operating procedure. Like this, you save time, costs, and prevent errors. Let's look at the requirements for an up-to-date data exchange. Encryption nowadays is definitely needed for any data transfer. There are different ways how to encrypt digital data. We are using the SSL/TLS standard, which is widely used by the web world. For example, all the HTTPS sites which you open via the browser are using this standard. This ensures that you as a customer do have full control over the encryption keys. This means you can any time decide to change the keys if, for example, the encryption was broken. Furthermore, since it is so widely used, it is safe and performant. We strongly recommend to work with certificates issued by a trusted certificate authority, since this is the way to avoid man-in-the-middle attacks. These are attacks where the attacker sits in between the communication of client and server and exchanges the encryption keys. This can easily be avoided by using production certificates issued by a trusted certification authority. An API should always be protected by an authentication mechanism. Like this, the API access is under full customer control. It is advisable to have a certain granularity regarding the permissions for certain operations via the API. Retrieving a dataset is for sure a very different story compared to creating, updating, or even deleting data. It is very helpful if you can grant these user rights already on the target system for the technical user that is used within the integration. In our example, we are working with a technical user used only by the automated data transfer to a specific endpoint. Like this, changes done via the API are clearly distinguishable from changes done by human users. One thing which additionally needs to be considered is that a technical user should have an own password policy. It must be possible to avoid resetting of the password after a certain time and to switch off the reset password upon first login functionality. If this is not possible, you are always in danger that your integration connection breaks down due to a simple password policy rule. As mentioned before, to guarantee the traceability of the data transfer, the response of the target endpoint must be documented either via audit trail or another log. Like this, we can always prove that a transfer was successful, or in case it was failing, we can ideally directly do some actions to repair it. It is required to use a protocol with flow control that ensures that the endpoint cannot be overloaded by too many received data at the same time. The client name of the endpoint and the username of the technical user must be distinguishable from human users. Last but not least, all changes on data. Another area you have to consider when doing an integration, like shown here, is the way how the export-import takes place. We recommend that it is a good practice to have automated export-import functionalities which avoid human errors, since they don't require any user action. It has to be decided where the approval of the analytical result takes place, either in the analytical software or in the LIMS directly. What typically always has to be done within Omnis is the reviewing of the audit trail entries related to the determination itself. All these things have to be considered when creating a new digitalized process. And last but not least, requirements regarding reporting and monitoring have to be taken into account. Do you need a trend chart? Do you need to create a certificate of analysis which is protected against manipulation? Do you have to define certain actions when a limit violation took place? Also here, it might be required to have an audit trail available to document out-of-spec events and reactions regarding these events. Here, a notification function might be very helpful to be able to react immediately on these events. As a short summary, I want to talk about the technical key facts of our integration example. We are using the widely used REST architecture based on HTTP methods and SSL encryption. With this way of implementation, you can use your own certificates and like this have the full control over the encryption keys. We have authentication in a basic way and based on the OAuth 2.0 standard. The integration is done such that we have a no-code mapping. Like this, you are enabled to react on new test plans, which require another or a new mapping of operating procedures to the test plans without the need to hire an IT specialist which programs this. So given the example, you have a new product where you have to make quality control for. So you can create, of course, the new operating procedures within the analytical software. You can also validate them in the analytical software. And then you are able to do the mapping according to the new test plan for the new product within one LIMS without the need for a new integration project. We have ensured full traceability. First of all, via using technical user in the user management and also via the audit trail, which documents all relevant changes on sample data. We can use notifications, for example, based on emails, in case of things are going wrong with the communication or things during your analytical run are going wrong, which enables you to react immediately on these events. The integration also works with other LIMS, LES or ERP systems. So we have an openly documented API which functionalities can be used by any other target endpoint system which offers a REST-based API exchange. And with that, I will hand back again to Philip, who will tell us about the advantages of a connected lab.
To bring this down on three most important topics and focus on the three advantages of a connected lab. So let's start with the organization. Most of you know how to work in a lab. There's a team, a lot of data, busy analysis to do, a lot of planning. And through connectivity, it enhances the work and the effort of planning to enhance also the efficiency and the capacity that can be used within a team and also within devices and instruments in a laboratory. The second point is also to keep an eye on the documentation. How much effort does it need to document every step, copy paste them from paperwork to different other tools and back then into the final source, and ask then the question, which will be the single point of source or truth. This brings me to the last point of the organization about the traceability, which we mentioned also at the beginning of the challenges in the laboratory, where the values are coming from. Are there kind of errors in the calculation or displaying some wrong numbers, which I can see, and uses for trend analysis and so on. So within connectivity, this media breaks and this potential errors can be reduced. The second topic is the notification and the communication, as well as the data streams. As Simon mentioned right the slide before about the reaction time and the downtime can be minimized through real-time data, and about real-time data that can be evaluated in a trend and can be see what kind of shift does these real-time laboratory data will have. This leads to a faster response time. If I get notifications on a push or even by mail, reduces the response time and the downtime immediately and save a lot of effort, and save some quality about the product, and also save some money within the quality control and the laboratory. And the last point of this main advantages is the resource management overall, which includes the other topics. As mentioned before, the capacity of the team, each of the lab technicians or the overall laboratory team can be enhanced and empowered to work ahead and plan better and use these resources based on the devices they have. Also to reduce the waiting time, because it can be tracked what is done in which status the sample or the analysis or even the QC order is at the moment, and can be followed up and reviewed instantly. And this leads to the final result, what every lab technician should have time to focus more on, is what they get paid for at the end, is to focus on the analytics itself, to do more analysis and to focus on the results itself. To see this also as key indicators and break them down to get it more precise, to have what we do in implementation projects. Based on Lean Six Sigma, we use tools to define the status quo of every laboratory. We measure them, we elaborate them, and after the implementation, after a settled time, we do this assessment again and revise and review them. And based on these real life key performance indicators, as we've shown now, we can see that the laboratory performance and the performance of the lab team can be enhanced dramatically with a connected and integrated solution. By standardizing the data which get handled in a laboratory and to manage them in a structured and homogenic way, the errors and the potential errors can be minimized by 75%. To break this down, even with the same amount of employees and the same amount of time in a laboratory, about the digitalized data and the processes to handle those data can be enhanced by 25%. And the last point is about single point of truth. And this leads the other way around to shorter communication and faster response times. So everyone has their data they need on one tip of a finger. And the last point is to have it centralized, all the quality data in one place, structurized, homogenized, and everyone can get connected. But the overall goal about this is to increase the added value through shorter, faster, and more efficient workflows. And by that, what that means and leads to is, at the end, overall for the company to better quality and better business decisions at the end. Because with that data, it can be worked and elaborated. To show this in a graph, about efficiency and effectiveness. So most of the companies starting at the red point and thinking of one solution, one digital solution that is that solution to all their lab problems. If they're taking their actual standard workflows they elaborated, which are complicated, error-prone sometimes, or sometimes even biased and highly complex, they try to digitize them in the best way, but at the end, they're still complex and error-prone workflows just digitized. So they can be automated, but the risks they included as manual workflows still occur. Our approach by digitalize and integrate a lab is to first look on the basics at the processes and the optimization of those to enhance the effectiveness of those first, step one, and streamline those processes and afterwards digitalize them. So at the end, there will be an increase of efficiency and effectiveness in 2 dimensions. And this can be implemented in a sustainable way. So in continuous improvement processes that they can improve by themselves and be digitalized through, as mentioned before, as routine workflows and also value-adding workflows can be automated. To bring this on one slide and conclude the whole webinar, the approach at this integration was to analyze the initial situation and to challenge the actual main problems in a laboratory. It means that the workflows has to be streamlined and get digitalized in the best optimized and leanest way. By elaborating this, we use different kind of tools and also exchange with a lot of lab technicians, lab managers, and quality managers to find a solution which is easy to use and can be set up from a lab technician with a no or low code solution. The third phase, then starting about digitalization, how we can bring this to a digitalized way by using a digital solution as a LIMS or another lab data solution. But this means to have lab protocols, minimized manual record keeping, and increase in that way the traceability. And if finalize these workflows are digitalized, we're focusing on the automation of the routine and the value-adding processes that are day by day done manually in labs today. So at the end, hopefully you can get some information and also hints and best practice out of this webinar today. And at the take-home notes in the last slide, I want to get over to Natalie and bring us to the Q&A session.
So thank you very much, Simon and Philip. This was a great and interesting presentation. So yes, we have some minutes left for answering your questions. We get already a lot of very good and interesting questions. So I will hurry up that we are able to answer as much as possible. So first question is, if new determination on the same sample overrides the result in limbs, does it require any confirmation? If not, how would that be justified to an inspecification? So I guess this question is for Simon, how we handle that in Omnis.
Yeah, thanks, Natalie. Good question, of course. This is something you have to consider when you do such an integration. In our case, we allowed this to show you that we have this flexibility. And we also have to add that kind of the key customers of OneLimbs are typically in the food industry, but not yet in the fully highly regulated pharma environment. You can make it such in Omnis that, for example, the user is not allowed at all to create a subsample newly, which is possible if you have an automated data transfer from the limbs. Then the user can only do the determinations which are sent to Omnis via the limbs. Another option is, after signing the determinations in Omnis, you can lock the whole sample and nothing can be added then again. So yes, it's possible to prevent this. And yes, in a highly regulated environment, this, as we showed it, is not doable without any modification comment or without any approval process behind.
Good. Okay. So talking about validation, this is a question for Philip. If data is sent automatically when determination is finished and measurements are signed in Omnis, is the measurement also signed in limbs?
Thanks for the question. So basically, we have an audit trail in the OneLimbs platform. And in the other way around, we have to export the orders to the system. And in that case, or in that example, it's Omnis software. And the other way around, we receive the values of this specific order to the specific sample. And this has to be imported through a manual step. And as we also shown in the example, that there can be a new iteration, which can be requested from OneLimbs. And there is no overwriting of any values. So the first place is to see it in the audit trail, and the second one is to add a new iteration. So the first value will be placed. And there is then at the end a check the checker. That means that the lab technician who check the analyzes